All right, this is going to be a little tricky. We're doing cross product again, and I want to do this because it's sort of a mass spectrometer style question, combining your centripetal force formula with your magnetic force formula. Though I sort of did a shortcut. Plus our lovely cross product form of QVB. So we want to find the angle between our velocity and our magnetic field. And we've got component form. So the easiest way to do that is we know the length of V cross B, in this case, is going to equal the absolute value of B or V times the length of V times the length of B times sine of the angle between them. So all we really got to do is find all that. So V cross B is, we just do it like this, do our whole, hey, I is negative 30 times negative 30 minus 50 times negative 50, we get 3,400. It's basically 2,500 plus 900. Anyway, so 3,400 in the x direction plus 1,600 in the y direction and minus 400 in the z direction. So that's our V cross B. And then if we want to find the length of that, we can dot that vector with itself and then take the square root, because if you dot a vector with itself, you get its length squared. Keep in mind, this is also exactly the same as 3D Pythagoras. So if you're like, what's this vector dotting with itself? It's 3D Pythagoras, or whatever D Pythagoras, because it works for however many dimensions you got. You can get more than 3. Anyway, so our x component squared plus our y component squared plus our z component squared, all square rooted, and it works delightfully. We end up with this pretty big number. And then we need to find the length of V and B. So we again dot it with itself and then take the square root, or just 3D Pythagoras. Notice I was a little loose with the negative signs because they just cancel it anyway after you square. But since we got sort of 20 squared plus 30 squared plus 50 squared, all square rooted, that's the exact same as 20 squared plus 50 squared plus 30 squared. So the length of V and the length of B are identical. And so if we multiply them together, it actually works out to this nice round number of 3,800. So they're really close. It's almost 90 degrees. So if we just divide this by that and then take the inverse sine, I didn't show that part. Hopefully that's pretty good. Just divide both sides by 3,800 and then take the inverse sine of both sides. We've got our angle between our velocity and magnetic field of 84 degrees. It's moving. It's basically circular motion. There's also the fact it is moving in a spiral. The component parallel to the component of the velocity parallel to the magnetic field is unchanging. If that component was 2 meters per second before, it continues to be 2 meters per second. But the rest of it, it's exactly like uniform circular motion from this year and last year. Just the net force equals centripetal force equals mv squared over r. So for B, the speed does not change as it moves. That its component parallel to the magnetic field is constant, and the rest of it is like it's uniform circular motion, just exactly the same. It's a perpendicular component, always has the same magnitude. Your angle doesn't change. I tried to show it here because basically your angle is kind of it's the angle between the velocity and the magnetic field, which is determined by your component, basically the ratio of your component of your velocity perpendicular to the magnetic field and your component parallel to the magnetic field. They determine the angle, and as we mentioned before, the perpendicular component, at least the magnitude of it, stays the same, and the parallel component to the magnetic field is exactly the same. And so you will always get this same angle here, and that's between right here, that guy. That'll always be 84 degrees for this particular guy until something changes, like the magnetic field changes or runs into something or whatever. Oh yeah, hopefully that makes sense. And then we kind of solved for the force already. I guess we did V cross B, which is equal to length of V times the length of B times sine theta. So if we just multiply that by our charge, we got the force. Normally we would do like QVB or QV cross B equals MV squared over R. But since we pretty much have force already, that makes things pretty easy. I rearranged it to solve for the radius, which is what we're looking for. Found the force by taking the V cross B and multiplying it by the charge of the electron. And then up top we got the mass of the electron and the velocity squared. It was 61.64 squared, which was 3,800, just like we found up here. So yeah, just rearrange, plug in numbers, and solve. Hopefully I didn't mess anything up here. If so, let me know and I'll fix it. Thanks for listening.